I'll now introduce rational expressions. And a rational expression is just a fraction. And in particular, it's a fraction that has a polynomial in both the numerator and denominator. Here are three examples of rational expressions: 7 over x squared minus 1, x plus 8 over x minus 2, and x cubed plus x squared minus x over x squared plus 7x plus 10. So far, we've really just dealt with polynomials, and polynomials are defined no matter what value of x we substitute in. I can stick in any value for x, and I don't have any issues. However, rational expressions start to give us an error. We have to consider division by 0. So we're going to define the domain. The domain is the set of numbers that the variable is actually allowed to be. So essentially, the domain is going to try to rule out whenever we have 0 on the bottom or whenever we have a negative under a square root. If we have a polynomial, 3x squared minus 2x plus 1, x can be any value and I won't have any issues. So we say the domain is all real numbers, which can be written as the interval negative infinity to infinity, or sometimes as this r. For a rational expression like this one, x minus 2 over x plus 1, we can see that if x is negative 1, that would be division by 0. So our domain would be all numbers except negative 1, because negative 1 can't be substituted in for x since we can't divide by 0. Another one, the square root of x over x minus 3. For the top of this fraction, we need x to be greater than or equal to 0 since we can't take the square root of a negative number. And in addition, we don't want 0 on the bottom, so x can't be 3. When dealing with rational expressions, we want them to be written as simply as possible. So in order to do that, we're going to use this property, AC over BC equal to A over B. This is known as the cancellation property. And essentially, if I have the same thing on the numerator and the denominator, I can cancel. One of the big issues that students try to do, though, is cancel whenever I'm adding. You'll notice I have a multiplication on the top, A times C, and a multiplication on the bottom, B times C. So I actually have to be multiplying things to cancel. So usually our first step would be to factor things. Let's look at this example. The top, the square or x squared minus 4, is a special factorization. It'll factor to x plus 2x minus 2. On the bottom, we need two numbers that multiply to be 10 and add to be 7. And we can see that that happens with 5 and 2. So now I have both an x plus 2 on the top and the bottom, so we can just cancel those. And that leaves me with the more simplified form of x minus 2 over x plus 5. Let's look at a couple more examples of this. 3x over 3x squared plus 6x plus 9. Well, the top can't factor since it's just a single term. And on the bottom, you should notice that they all have a 3 in common. Removing a 3 leaves me with x squared plus 2x plus 3. I now have a 3 on both the top and the bottom, so I can cancel just the 3. This leaves me with x over x squared plus 2x plus 3. Let's look at one last example, x cubed minus x squared over x cubed plus 4x squared plus 4x. The top has an x squared in common, and I'm left with x minus 1. The bottom has an x in common, and I'm left with x squared plus 4x plus 4, and that continues to factor, so we're going to go ahead and do one more factorization step. This actually factors into x plus 2, x plus 2. So now I want to be able to cancel. On the top we have an x squared and on the bottom we have an x. So I can get rid of this x and I can only get rid of one of the x's on the top because I only have one on the bottom. This leaves me with a final answer of x minus 1 over x plus 2 squared.